Let's now look at some examples. So this first example is bias in a study. Suppose a mathematics department at a community college would like to assess whether computer-based homework improves students' test scores. They use computer-based homework in one classroom with one teacher and use traditional paper and pencil homework in a different classroom with a different teacher. The students using the computer-based homework had higher test scores. What is wrong with this experiment? Okay, so what I am seeing is that you're having two different teachers teach this using two different methods. So we have different teachers. So the idea to fix this would be to split, if it wasn't already done, but assuming because it wasn't stated, we'll say split the students randomly among the two groups. Then have the same teacher. This way, the only difference that's happening is the thing that we want to test, which is, will they do better on computer-based or traditional? So there still will be a variability among these students, but by utilizing this same teacher and randomly assigning them to groups, this is going to reduce any confounding variables that might occur. The next example, we want to determine if the one variable did cause a change in the other. Cinnamon was given to a group of people who have diabetes, and then their blood glucose levels were measured a time period later. All other factors for each person were kept the same. Their glucose levels went down. Did the cinnamon cause the reduction? So we noticed that the cinnamon was controlled and all other factors were kept constant. So when you have that, then any change in glucose can be attributed to cinnamon. This is an experiment, correct? Because you're controlling one, you're giving to a group of people. So because it's an experiment, you can say it causes the reduction. So yes, everything else stays the same. So you could say that cinnamon caused the reduction. So there is a link between spray-on tan products and lung cancer. Does that mean that spray-on tan causes lung cancer? So again, we're talking cause, which is referring to an experiment. However, we're not doing an experiment. We're actually just observing, because they're saying there's a link between tanning products and lung cancer. So no actual experiment was conducted. So we can say, since there is only a link, not an experiment controlling the use of the tanning spray, you cannot say that increased use caused lung cancer. So instead of saying tanning products cause lung cancer, you could say tanning products are linked to lung cancer or associated with lung cancer, but you cannot say are caused. Again, because it is an observational study, not an experiment. Nothing is being controlled. Okay, moving on to generalizations. A researcher conducts a study on the use of ibuprofen on humans and finds that it's safe. Does that mean that all species can use ibuprofen? Okay, if you go back up to generalizations, know that because it was proven safe on humans does not mean you can apply it to other species. So we're going to say no. Just because it is safe on humans does not mean it is safe for all species. And as a side note, ibuprofen is toxic to cats. So good thing we didn't generalize this to all species because cats would not be doing so well. The next example, aspirin has been used for years to bring down fevers in humans. Originally, it was tested on white males between the ages of 25 and 40 and found to be safe. Is it safe to give to everyone? Again, no. And it's the same reason as above. Just because it is safe on white males between the ages of 25 and 40 does not mean it is safe for others. There's actually a link, so that means it was an observational study, not an experiment. A link between giving a child under the age of 19 aspirin when they have a fever and Ray's syndrome. So there's a link between giving a child under the age of 19 aspirin and Ray's syndrome. So again, we're not going to want to generalize. So an example of a bias sample, in 1936, the US presidential election had a poll and it predicted Alfred Landon would win by 57% of the vote. The actual result, Alfred Landon won 37% to 61% for Roosevelt. They were wrong by 20%. So the reason why was because the polling techniques were not good. First, they sent out 10 million ballots, only 2.4 million returned. So non-response bias, correct? They surveyed its readers, car owners, and random telephone numbers. So this would be sampling bias because they are sampling those who may have a particular opinion than the others. Because you can see here, all these groups were high income. Also, the non-response rate was high, which we already talked about. Those who didn't respond were different from those who did respond on average. And here's some more information if you're curious about that. And here is a video that puts a lot of chapter 1 all together. So if you kind of want a combined synopsis of this chapter, go ahead and watch that. So you'll notice that this chapter really lays the groundwork for statistics and just gets you familiarized with basic concept and terminology, along with how to collect data. In the next chapter, we're going to learn how to organize that data into meaningful visual representations.